Hello everybody, welcome again to this lesson. Today we're going to talk about differentiation by first principles, and I'm going to use this illustration to show you how it works. So here we have a curve, and this is the curve of y is equals to x squared. Okay, and in this curve we have three chords called AB, AC and AD. Okay, now you should know that in functional notation y, for example, if you have y is equal to x squared, this is the same as f of x is equal to x squared. Okay, so in this case, if you were to get the gradient of this chord AB, the gradient of this chord AB, f of x will be f of x, which is 3, minus, this is called AB, f of x minus f of y. Okay, all over 3 minus 1. Okay, and this will give us f of x. F of 3, just replace 3 in place of x and you get 9. That will be 3 squared, which is 9. And if you replace 1 in place of x, 1 squared is 1, divided by 2, which is 4. Get the gradient of chord AC. Chord AC. Chord AC, f of 2 is f of 2 minus f of 1. Okay, 2 minus 1, 2 minus 1. Okay, this is called AC, and we're getting its gradient. Okay, it will be f of 2 minus f of 1 over 2 minus 1. Okay, f of 2, replacing 2 for x, 2 squared is 4, minus 1 squared, placing 1 in place of x is 1. Okay, 2 minus 1 is 1, and this will be 3 over 1, which is 3. Let's carry on. Let's get the gradient of chord AD. Okay, so these are the gradients of chord AB, AC and A. So let's say we take a we assume a point F, so close to, very close to A, very close. Let's say AF, a point AF, a chord, a point that makes a chord, a point F so close to A that it makes a chord AF, and let's say it's 1.1. So F of 1.1, okay, minus F of 1 over 1.1 minus 1. Okay, so replacing 1.1 in place of x will be 1.1 squared. This is 1.21 minus 1. 1.1 minus 1 is 0.1. So 0.21 divided by 0.1 is 2.1. Okay, 2.1. That's the code AF, and F is very close to A. So let's take another point G, so that we have the code AG. Okay, so that we have the code AG, again very close to A. Let's say 1.01. So that we have 1.01, very close to A, minus F of 1 all over 1.01 minus 1. So what do we get here? Replacing 1.01 in place of x, we'll get 1.01 squared, which is 1.02 minus 1 all over 0.01. 1.01 minus 1 is 0.01. So 0.2 divided by 0.01, we get 2.01. Okay, now you can see from this illustration, you can see as B moves closer and closer to A, it is approaching a limiting value, which is 2, a limiting value 2. It is going closer and closer to 2, which is called the limiting value. Okay, as it approaches, it will go like that until when it is finally at A, it will make a tangent at this point. Okay, so as B moves closer and closer to A, it is approaching a limiting value 2. Now from this illustration, we want to derive the first principle formula. We have a curve and we have 2 points A and B, which make up. And now in order to get the gradient of this chord, first of all, this is x, and let's say we have a really slight change. It is a really small chord, and there's a very small change in x, which you have named here delta x, and also a very minimal change on the y-axis, delta y. Okay, so in order to get this gradient, we need to get dy dx. Okay, so in order to get the gradient of this chord, it will be simply, so this is f of, to get this the gradient of this chord, it will be f of x plus dx minus the f of x there, this is called AB. Okay, all over x plus dx minus x. Okay, so x and x will cancel here, so we are remaining with f of x plus dx minus f of x all over dx. So the smaller this gets, the smaller this dx gets, the delta x gets, the closer you approach the limiting value. So the way this is usually illustrated is that it will be dy dx of the differentiation of AB, limit dx with limit dx tending to 0 will be equal to f of x dx minus f of x all over dx. Okay, limit dx tending to 0, because as b moves closer and closer to a, it will approach a limiting value. Okay, and dx ultimately will tend to 0. Okay, that's why we are putting this dy dx, which is the differentiation of the curve, with limit dx tending to 0. Okay, so this right here is the formula for differentiation by first principle. So in our next lesson, we'll tackle some examples. We'll do some examples involving this. Okay, thank you for watching. This is Understanding Math.